Well, hello everyone to this presentation about AI, crypto, and security. As an introduction to myself, my name is Pablo, and I'm currently part of the core team at Spearbit and Cantina. Spearbit is a Web3 network of decentralized security researchers. We work with high-profile clients and on very complex topics. And Cantina is a security marketplace and also a code review platform, as you could say, where we are building a whole set of new AI tools that are also relevant to this topic, and that's what I wanted to bring to the table. So, just to get a glimpse of what is going on, you have probably heard of AI, crypto, agents, decentralized finance AI, and security, right? Well, probably in this context, not much about security, but soon you will. And this is a current topic of interest. Everyone is talking about it. And as you can see here in the Google Trend dashboard, the mentions of crypto agents and DeFi have skyrocketed. And there is a lot of money that has been invested in this place. So it's definitely not a trend to fade and to ignore. But this doesn't come out of the blue, out of anywhere. There must be a way. Why did this all happen? It's not that one day folks woke up and say like, I feel like making a new trend. It's gonna be called DeFi. Yeah, and everyone just like gathered together and started talking about it. There is actually a very long history in the AI academic and research space, and we are just in this 2025 box where everyone is talking about the autonomous agents, but lots of development happened before that, such as ChatGPT and the Transformers architecture and CNN's backpropagation, lots of math formulas and so on. So we are just in the right moment and the right time with these new AI agents. And I think it is important to mention how it was picked up by the crypto Twitter community, because before there were AI agents before. People were using different frameworks and they were using LLMs for simulating agentic behavior. But then suddenly everyone on crypto Twitter started talking about it. So just to put everything a bit into perspective, 2024, meme coin narrative. Everyone was aping here and there. And in parallel, there were already people that were working on agentic systems, such as plugging large language models on Twitter and allow them to interact with users. And one of these models, like one of these systems, is called the Terminal of Truths, which is an autonomous or pseudo-autonomous agent that was plugged in Twitter and was interacting with users. And it was also interacting with Mark Anderson, one of the co-founders of A16Z, one of the most powerful VC funds there are. And it was this interaction was what changed everything. Essentially, this bot kind of convinced Mark Anderson into investing into him so it could become better and buy more GPUs, improve the infrastructure to become even more agentic and autonomous. And here you can see the conversation. It's very interesting to follow with. And Mark was convinced, and he said, "Okay, your terms are acceptable. Give me your Bitcoin wallet address, and I will send you $50,000." So this could be the first time that AI agent has actually interacted with a user, and the user has sent this person, to this agent, $50,000 to a crypto wallet. Now, everyone was freaking out, like, what is going on here? And everyone started paying attention. And after that, the developer of Truth Terminal launched a token, the first ever meme AI token. That's Goatsus Maximus on Pump.fun. And some folks think that it was launched by the AI agent itself, but it wasn't. It was launched by the developer, but the Truth Terminal played a huge role on promoting this token. Well, this terminal, obviously, and also folks like Arthur Hayes. And so this token, the value skyrocketed. It was like the first token backing an AI, and everyone wanted a piece of the pie. And AI16Z came up and said that, oh, that's fine. Now we're going to create an agent that is going to outperform the investments of Mark Anderson. And instead of calling it A16Z, such as the real name of the fund, it's going to be called AI16Z. And the idea is to let users participate in a VC fund and make money. So the challenge is still going on. These AIs are trying to outperform Mark Anderson's investments. And after all this like narrative, now we are in the moment where there is lots of agents being launched and they're being tokenized, and you can buy them by their token using like the Pump.Fund business model, such as what Virtuos Protocol has and many others. And the interesting part is that A16Z at the end of early December, 4th of December, if I recall correctly, they released their A Few Things We Are Excited About in Crypto 2025 article. One of those two things that they are excited about in 2025 are dedicated crypto wallets for AIs and decentralized autonomous chatbots. And this also puts everything into perspective and sets the stage for the narrative of 2025 and ahead, where AI agents will be able to have access to their own wallets and manage assets and sign keys and even operate or validate in decentralized physical infrastructure. And also, if they're like really autonomous, there's gonna be even more advances in technology, such as in the trusted execution environment side, in order to create truly autonomous agents that can manage not only assets, but interact with the crypto community or help manage proposals on DAOs and all that. So this is gonna be very important in the next months and also years. And there is, of course, always a reason for this to happen. And mostly it's because better models increased adoption. Before, everyone was already talking about AI agents. This is not a new topic, but the models were not good enough to allow LLMs reason properly or interact in such a way that could make it look like they have a character or certain behavior. Now, with the development of large language models and better reasoning engines and higher context windows, this is what also makes all this new space possible. So we have models like OpenAI, Anthropic, Gemini, X. These are closed source models, so you don't have access to the code to see like how it actually works. And then you have open source models such as Mistral or Llama, or how about that? Now we have DeepSeek, which is a model that was released a previous week, and apparently it's almost outperforming the most powerful model there is, which is O1 by OpenAI. And yes, DeepSeek is open source. And if you dig a bit more into DeepSeek without going into technicals, a lot of the training set has been synthetic. So it imitates the ChatGPT's kind of answers because it's trained against this other model. So LLMs, we are gonna give you, this is a quick intro to LLMs, but you don't really need to know exactly how this transformer architecture works. Just understand that most of the LLMs that you're gonna be using have the transformer architecture or some part of it, right? Like such GPT is a generative pre-trained transformer. BERT is the bidirectional encoder transformer. Roberta, Albert, all of these are variations of the same architecture. And if you really want to learn more and get an intuition of how this works, I highly recommend these 3 links on LLM visualization to see how everything works, even at the matrix multiplication level, the illustrated transformer, and also a course on NLP, in order to understand that at the end of the day, these are stochastic parrots, or their job is mostly to predict what is going to be the next word based on the previous context. This sentence, what I just said, is very important, like predicting the next token or the next word using the previous context is what makes you understand what are also some of the differences between in LLMs. If you have LLMs that are trained only for language, let's say only for law stuff, like law GPT, then if you're going to ask that model about how a reentrancy attack works on Solidity, it may spit out some facts, but it probably are not going to be very accurate, or maybe it will start hallucinating. So do take into account that there's models for different purposes. The general text ones, such as GPT, BERT, Llama, if you're more looking for coding-based models, then you have CodeBERT, Codex, StarCoder, and so on. And the way that you interact with models in general, based on context, it matters a lot, because at the end, like, LLMs are context machines. So what we do is we prompt these models in order to get an output, to get an answer. And by prompting, we give the model a specific instruction or input in order to guide it in a particular way, or to perform in a particular task in order to generate the output that we desire. So if your prompt is bad, it is likely that the output that you're going to get is not as high quality as it could have been if you have really engineered your prompt correctly. You can actually get up build anything, any agentic system nowadays. There's like many tools to build AI, to build these AI systems. You have libraries, like LangChain, LangGraph, Llama Index, and then you have frameworks like Baby AGI. And these are very easy to get started with. And also, there's a lot of documentation. LangChain, for example, is if you don't want to have create a framework or to use a framework, you can use LangChain as a library in order to create different prompts and chain prompts in order to achieve actions that you define. And for frameworks, you already have like some sort of plug and play software where you only change a couple of parameters. You input your OpenAI API key and an environment variable and some more parameters, and then the agent is already able to take your input and perform tasks. And I think it's also important to mention that the agent framework that made all this viral, it's AutoGPT, and it went viral in 2023. So people were working on frameworks for a long time, but the one that made things go viral is AutoGPT, created by Torrent from Significant Gaming. And it's a multimodal and a visual building framework. And by multimodal, I mean that it doesn't only support text, but also audio and images. After AutoGPT was created, Baby AGI came in, which took a lot of ideas from AutoGPT and just tweaked them a bit in order to create a framework only specialized for task management. So it has the framework provides the agent with much more autonomy and simulates human processes more than, for example, what AutoGen would do, which is it spawns up a virtual environment and allows you to create multiple agents that interact between each other in some sort of collaborative or / adversarial way in order to achieve a task, right? And this framework, for example, has things that other frameworks don't have, such as an OAuth for API integration, or it allows for a human in the loop to be present. So something very cool that if you notice the OSS is that all of these are open source. So you can anytime look these ones up and experiment and play around and see which one fits your purpose much more. And I've been playing with all this like way before 2023, actually, but in 2023 is where I almost made the mistake of deleting my system, not only once, but twice. Yes, I did manage to do that. And the whole purpose, the experiment that I was trying to achieve here is that, okay, what if I don't have time to actually compile a Solidity code base because I have like something else to do. It would be amazing if I had an agent that I could give an instruction to, and the agent would do the stuff what I want to do. In this case, make sure that there's tests in this code base and they are and they pass. Right. So what I did here is create a lot of chain prompting using LangChain, and finally ask the agent go to this link, and the agent would download the codebase repository from the link, then navigate into the directory. It will know which command it needs to run in order to compile the code base and which command it needs to run in order to execute all the tests. And of course, in order to do this, I had to give him access to the shell and system commands. And right, if the agent is not very smart, if the underlying LLM is not very smart, or if it gets stuck in some sort of loop, probably what happened here is that the agent downloads a repository, but is not able to navigate into it. So it's going to restart the whole process. And before restarting the process, it's going to say, I am going to delete this repository to start clean. And instead of deleting the repository, it deletes your system. Yes, this happens. So be careful with what kind of access you give to these systems. And talking about access, in the crypto AI agent community now, these agents have access to crypto wallets, which is not only fascinating, but it also introduces a whole new array of vulnerabilities and ways to exploit them, but also introduces a lot of opportunities for regular users. And so this is a very exciting moment. There is a multiple ecosystems on this crypto AI agent space, but the three most interesting ones are Virtuals Protocol, AI16Z, and Arc. So all this, they have an ecosystem, like a community support and so forth, and also a framework to build agents. And Virtuals, for example, is very interesting here because it already allows folks to tokenize their AI agents and participate in their revenue generation. So if you're familiar with an agent called AIXBT, it is not developed, or maybe it is, we don't know. It is most likely not developed using the traditional game framework. That's a virtual agentic system framework, but it has a token. People can buy this token, and based on the amount of tokens that someone has, they get access to AIXBT's private features, such as like a private terminal, which you can only access if you have equal or more than 600,000 AIXBT tokens, right? So this already allows users to participate, to engage with these agents, and also to participate in their future. AI16Z, they have a token, but they don't have a way of tokenizing agents yet, but they do have a very, very good framework, which is called ElizaOS. Amazing work to the team that is building this. They're building very, very fast and integrating a lot of crypto features in it. And a lot of people are actually using ElizaOS in order to build their own agentic systems for different reasons. And we will go into why AI16Z is also very interesting and why so many people are using it. But also we have Arc that has created a Rust-based framework. And the Rust scraps are that developers, extremely smart and talented people, and they already have a systems thinking kind of background. So you can expect amazing things coming from Arc. And the reason I primarily mentioned these three, it's because of they're the top three on the market cap, right? With a very big percent of the market share and 2 billion 900 million 400 million of the market capitalization, which is a lot considering that these ecosystems are so young. Out of a total market cap of 14 billions now, it will probably go up in the future or go down, but this technology is here to stay. And there's also like many other different apps, such as Griffine, which allows people to create or manage different AI agents. I'm not really sure. It's probably infrastructure. It's closed source, so I haven't really looked much into it. But other apps, such as Top Hat, Creatabit, Waifu AI agent layer, they're following the Pump.Fun agent launchpad business model, where they essentially allow someone to launch a token in a Pump.Fun way. And when it reaches the bonding curve, the liquidity is then moved towards an automated market maker, and then folks can tokenize an agent. That's pretty much it. But they do not allow for such, they don't have their own framework. Maybe they're working on it or not, but they do not allow for streaming action such as Virtuals protocol does. Virtuals is much more, it's much more mature in this case. And looking at some of these crypto agents that you may have seen around, on the left we have AIXBT, a market intelligence agent. We do not know what kind of framework it's using, but we know that it was launched on Virtuals. And what it does, it's interact with users on Twitter, and it has access to a lot of on-chain data and maybe lots of different tools to do analytics on different coins. For now, its output has been very impressive and very good. It's actually the agent that has the most amount of market share, of mind share between users. And its interactions are like genuine. They feel genuine, and their own. It has like its own personality, and it has a lot of data, and it's made a lot of very interesting calls. We don't know if it's exactly very, very autonomous. Most people think it's not, that developers are able to, influence their input. And some people would also say that because they can do that, then they are making the agent pump some tokens, are maybe not pump others. And then on the right, we have PMarca and the agent Spartan AI, which are built using the ELIZA OS framework, and they are managing the AI16Z VC fund. So this is very interesting because these agents, they manage all the tokens, buy and sell based on current market sentiment and interactions with users. So they interact with users, they collect some insights from the users, and based on the quality of those insights and other different information framework pipelines that they may have in the background, they create decisions. And those decisions are to invest in this token or to sell this one. And that's how they're managing this AI16Z fund, which is mind-blowing. On the right, you have arguably one of the most and the coolest exciting experiments that have happened with autonomous agents and TEEs. And my pet rock is an agent that has access to a trusted execution environment. And the keys for the agent, the Twitter keys and the email, have been generated on a TEE, so the developers don't have access to it anymore. And the agent is tweeting, and there is no human interference. That's pure autonomy. You cannot say that from other ones because we cannot prove it, but we can prove it with this one. And there's several examples, such as on the bottom left, AI Idol. Very interesting, using the game framework by Virtuals. It also has its own token, and it also has access to the metaverse and a virtual space where people can interact with it, such as as you see here in this TikTok style. And you could send funds to it. You can have to buy its token, and then you can send token for it to do actions or whatnot. And I saw it there on TikTok, and I said, I cannot believe this is a real agent. And then I checked it out on Virtuals, and it had this live stream that people were talking through as if it was a TikTok NPC. And I asked it about reentrancy vulnerabilities, and it actually replied. It was very, very fun. And another important and notorious agent is Freyza AI. You may have heard about the security researcher that convinced an AI to send him $50,000. So this is a game that's its purpose. And if you haven't seen this seminar by Popular, that's the name of the security researcher, 100% recommend you do. It's amazing. So you see that there is so many agents, so many things happening, and no wonder why all the users now and all these traders, market participants, and folks from different spaces are saying like, wow, like decentralized finance AI, it's like a total revolution. Like, this is very interesting. You have agents that have access to real-time market data and also can interact with users. And based on all these different factors, they can move crypto funds around because they have access to a crypto wallet and they can make the best decisions. So this is truly revolutionary and truly interesting. We'll see where it goes. So as a quick, too long didn't read, we have ELIZA, which is a framework developed by AI16Z on TypeScript, and the whole value proposition at the very beginning was venture capital DAO. That's what we mentioned about having PMarca and DJ Spartan AI manage a fund and buy or sell tokens based on what users say. Users that all, of course, have the proper token in order to get access to these private channels. Then you have the game framework developed by Virtuos Protocol. For the AI idle agent has been developed on Game. Many agents that are launched on Virtuos are also using the Game framework, and it's using Python. And it allowed its value prop was mostly coming from the gaming side of things, so virtual metaverse interactions. And then we have Rig, this other ecosystem, which is built in Rust. And a couple of three very interesting mentions is that Pippin, a new framework that probably will go open source now, but that is the creator of Baby AGI, and he just joined the game. So Baby AGI is, as you see here, one of the most starred repositories on GitHub, and he's an extremely talented and smart person, and he got in the game. So now big things coming, most likely. And then we have Freyza and AutoGPT. Just have to mention them. And as a side note, whenever you're interacting with an agent, like how do you truly know that it is an agent, right? I was talking to Brian Armstrong, and I actually expected Brian Armstrong to be a full agent, maybe not autonomous, but be able to have access to tools and to a broader knowledge database, because when I was interacting with it, it wasn't really giving me a lot of the information that I wanted to know from Brian Armstrong, or it couldn't do anything else. So you just have to open the inspector tools to find out that this was just an LLM wrapper. And also they made a mistake and leaked some of the 11 API keys. So yeah, be careful when you are developing these LLM wrappers, right? So is it true that AI agents are just LLM wrappers? Has this been all a lie? Maybe it's time for us to understand what is it an agent? Is an agent just access to an LLM and some very, very complex prompt engineering, as we spoke about before in the presentation? So we're defining roles, we're creating a personality for a character, we're giving this extra contextual knowledge. Okay, so let's build our own agent, right? We have an LLM. Cool. But what next? If I speak with the LLM for a very, very long time, at some point it will forget about my name, and that will make me extremely sad. And it will also forget about other kind of interactions, because LLM models context window is only so big, and you can think about it as a queue. So you start putting content in, and at the end it's gonna either overflow on some point, or the model itself is gonna tell you like you're out of the context window is out of bounds. So you have to manage the context window properly. And in order to add even more information to a model, then we need a database. In this case, it's going to be a vector database where we can store embeddings. And then this can be accessed or retrieved based on the relevance of the content. And the content can be passed to the large language model. And this is how we have long-term memory. And you could even argue like infinite memory, as much as storage you have, at least. Okay, fine. So now we have an LLM we can interact with a personality, with some rules of engagement, with some extra knowledge that we have provided with this vector database. So now it remembers my name. It remembers a lot about important interactions. If I heart it, then it's going to remember. If I make it happy, it's going to remember. Cool. Is that it, or do we expect more from an agent? We need this agent to be able to also like make decisions, right? So we give him a decision-making module, so it can break down goals and tasks into subtasks. Okay, that's great. And what else? We should also give him access to an external environment, such as tweets from X or X. I don't know how you would call it nowadays. But now we can grab everyone's tweets and take them and put it into our database. Or we can also look at the interactions of users on Discord and also interact with these users on Discord. Our access to the internet directly. So it can go read about research papers and call different APIs in order to know what's the weather like today, which is cloudy, if you were wondering. So it also needs to execute tasks, right? Because we wanted to have some agentic behavior, not only access to a lot of like different modules. And so to execute tasks, we have to give them at least function signatures or a way for the model to execute these tasks. And whenever it has executed a task, how does it know if it did it wrong or if it did it right? And if it is going to make the same mistake over again? Well, in that case, we will also need to have a learning module so the agent can learn from previous interactions and become better and improve and not make the same mistakes that it did. So, okay, is this an agent yet? It's not the same as just a simple LLM wrapper, is it? There is a lot going on here now. It's a whole framework that we built. And the question is that, okay, if this is an agent, is this autonomous? Like, what's the autonomy part of it? Is this autonomous? Well, no, it's not autonomous, because in order to make something autonomous, you have to slap some TEE on it. And that's the example that we mentioned before about my Bedrock agent, is that the creators generated the API keys and the emails inside of a trusted execution environment, such as this enclave, that only can be executed inside the CPU. So as soon as these folks generate all these keys, they don't have access to it anymore. So now this agent can operate without human interference. And because the TE can also generate some sort of proof, you can actually verify that the code that is running has not been altered, and therefore there is no human interference. And that's how we get the autonomous agents. And also a very, very quick mention on RAGs, because RAGs are the way of creating these databases for the agents in order to have access to extra knowledge. That's what we talked about, like long-term memory, or like remembering a lot of different interactions and things about the user or so on that do not fit in the context window of the model. You create RAGs in order to have facts, things that you know that are 100% true, because the LLM is going to hallucinate. There is actually a very, very interesting article, I think it was by MIT, which is called "LLMs Are Bullshit Machines." If you want to check it out, have a look. They had like they were talking about like different ways on how LLMs were actually like hallucinating content and how that created problems. One of the problems that it created, just as a side note, is that they provide information in such a way that it looks factual. And there's been this case not long ago of a lawyer in the United States that used ChatGPT in order to generate some proof for a case, and the judges found out that all these cases that the lawyer provided as a background, they were not real. They were just completely made up. And they actually had to scold the lawyer and say, like, man, you cannot really do this, right? So that's why you have RAGs, where you have actual facts and information. So most of the times you might need RAGs instead of fine-tuning, but two very interesting components here. It's a tokenizer and an embeddings model whenever you're creating your agentic system, right? So a tokenizer, at the end of the day, what it does is split the text into smaller and standardized units, the tokens, before embedding them. So you're ensuring that it's consistent, and this gets a meaningful representation, and also they directly influence the quality and accuracy of the custom embeddings that you're going to create for a very custom purpose. And the embeddings model is what is transforming all these tokens into vectors with a lot of numbers in order to capture semantic relationships. So a custom model, for example, if we want an agent system that is focused only on crypto security, maybe using a generic framework system with access to a generic large language model, it's not the best way to go in the future. It's good as a foundation, but it's not the best way if you really want to maximize output quality, right? So then you would create a custom tokenizer and also a custom embeddings model. So you can ensure that there is a more precise and context relevant embeddings in order to do semantic search and create recommendation systems and also topic clustering. So the tokenization, this is how it would look like if you're just passing a function, right? This is the general tokenizer, the tick token for GPT-4, if I recall correctly. And this is how it breaks it down into tokens. And all of these tokens are then created into embeddings. So this can give you an idea, or at least a glimpse for the intuition that if you have a custom purpose tokenizer and embedding, then maybe this function would be broken down in a different way, and the embeddings would be created in a different way, which means that it will allow you to be much more, let's say, precise, and it will allow you to represent these things in the semantic vector space in a much higher quality way, right? So imagine that a custom security focused model embeds the word reentrancy and here it would in a context of smart contracts and vulnerabilities and best practices, and it will match it with things that are like less broad. That's what general models would do, such as I don't know, less specialized associations. But a custom embedding model will associate that with probably with function call and smart contract and I don't know, like .call value and whatever. So it will create like better groupings and relationships. And especially if you're building racks, you probably do want to have your own embeddings, your custom embeddings model for whatever purpose it is doing. Most of the time, it's good to have to use a generic one. But whenever you're doing things here, for example, as saving tweets based on different content, and then you are breaking down this content in different analysis, and then you want to have very specific as word associations that you want to capture with these embeddings in order to retrieve them much more efficiently to give them to users, then that's something to consider. But otherwise, don't overthink it. So after this side note, what is an AI autonomous agent really? We know that an LLM is a type of machine learning model designed for natural language processing tasks such as language generation. So with context, it predicts what is the probability of the next word coming out. Autonomous, from the Cambridge English Dictionary, says that it's an independent and having the power to make your own decisions. An agent, also from the Cambridge Dictionary, it's a person or thing that produces a particular effect or change. So based on everything that we've learned so far, we now can create and understand what is an AI autonomous agent. And that is an LLM-driven system that independently makes decisions and acts to produce specific effects or changes. And most of the frameworks are always going to look alike. They're always going to be the same. It doesn't matter what kind of AI agent system you see. It's going to be very similar if you compare it to another one. Most of them are always going to have a task planner or access to a memory module or access to an external environment, especially if it's interacting with your users, or if it needs access to APIs or internet connections or tools. So it doesn't matter if you're building an agent to create a VC fund or to help you with some workflow management tickets in your company or community management or whatnot, the framework architecture is always going to be very similar, and then you can customize it based on your personal case, such as, for example, what AI-XBT did. This is an image from a user that was attempting to reverse engineer the AI-XBT framework, right? And as you can see, it still has this external interaction environment module, external interactions. It takes information from the on-chain indexers. It also uses an LLM engine. It interacts with users on Twitter. So it has this engagement manager and so on. So you see that it still uses many of the patterns that we have seen before. Or other users start building their own system, their own agent, and then they decide that it is not fulfilling their needs, and they have to completely switch. Like this user that was either using Virtuals or Elisa OS, they said that we're not going to use those frameworks anymore. We're going to build our own because we want to incorporate a new methodology called reflections, right? So take into account this, that if you want to either evaluate or build your own agent system, most of the times it's always going to be looking the same. And for the infrastructure side of things, the most important part, of course, is the hosting and the memory management frameworks of the LLM itself. But there's like this whole stack where you have chips and different companies such as NVIDIA, Intel, or Groq producing these AI-specific chips, and then hosting providers, any of these that you may use, such as Amazon, Microsoft, Google, for LLM operations, such as like creating training pipelines and monitoring these, such as 1DB. What do you call it? What's called 1DB? Oh, sorry, yeah. Weights and biases, 1B. And I used it before. It's very helpful in order to get some statistics and monitoring the performance of your model when it's being trained. So there's all this whole part of the infrastructure stack that you should be using on your advantage. But so developing these systems is not just, many times it is plug and play, as we saw before, but there's lots of problems actually. So that's why many people end up going back to the traditional methods, because these frameworks and systems, they promise a lot. They can do a lot if you spend enough amount of time and money on it. But essentially, there are many problems that you are going to have to tackle, such as one that is very common is the loops, the LLM agent loops. So the LLM agent, it tries to fix a problem, and then it gets the output, and then it changes the code again in order to fix the error, and then it executes again, it generates an error, tries to fix it, and it keeps on going in a loop, and that, of course, ends up costing money. Also, the capability of the underlying LLM is very important for your agentic system. Most of the time, you're not going to be able to host this locally, right? Because they are very dependent on hardware requirements. So you can figure out that Sonnet and O1 have much different requirements than Llama, for example, at the hardware level, right? So even if you host a Llama model locally, because it has like different parameters, different number of parameters. If you're hosting like the largest one, probably I think it's like 80B right now, and your system cannot handle it, then it's just your computer is going to blow up. So you're going to have to use the lower parameter model. And if you're using the lower parameter model and their system is still not good enough, then it's going to be extremely slow. And just because it has less parameters, its output is already a bit lower quality. And if you really wanted to make it work on my small laptop computer, then you could do some quantization. But as soon as you do, it's okay, cool. You can run your model locally, but there is going to be a significant drop in quality, and therefore you should not be using it to have an agent that is going to be doing crypto transactions, right? For obvious reasons. And speaking about crypto transactions and models with access to crypto wallets, Elisa OS, for now, it's probably the most advanced in this space, since can create a crypto wallet, it can do web search, it can execute smart contracts under a self-conscious mode. So ELIZA OS is the first AI agent framework that has access to a lot of these crypto features that others don't have. And with that also comes a whole new array of potential attack vectors, such as prompt injection. So if mentioning popular ones again, the way that he managed to trick an agent in order to send him $50,000 was by engineering a very specific prompt. And he knew how to do that because he understood how the semantic vector space worked. And you could be able to trick these AI agents into sending you money or sending in money somewhere else or resulting in loss of user funds. Or if the AI agent has access to interactions with smart contracts, then smart contracts can end up exploiting this agent in one way or the other. Because if the agent is not able to verify the behavior of a smart contract before execution, then it could get phished, right? Or if the agent has access to the internet, then an attacker can craft a link in this particular way and convince the agent to click and sign a transaction and steal all the funds from the wallet or whatnot. So there's like many things to be scared of, especially with these AI agents that have access to user funds directly. And we definitely need more security threat models and practices for these new systems. And especially the space is developing so fast, then a supply chain attack is probably going to be one of the hard-learned realities. To have some North Korean hackers just inject some code, because if you see like the ELIZA OS framework, GitHub PRs, they're shipping nonstop. So hopefully we don't get a backdoor nor anything like that. And speaking about security, right? There is right now a bit of and there is going to be a bit of a problem in the security space because everyone has access to LLMs. So anyone can create applications, ship them because they have access to tools such as GitHub Copilot or Cursor on Replit. So the output has actually increased by a significant amount, which means that bugs in code have also increased by a significant amount, right? Because we have a whole new era of developers and software engineers joining this space that have not had a proper foundational education on how to think algorithmically or how to properly plan. Then they're going to do everything with AI because that is the current coding paradigm, like it or not, and it's going to keep on being in the future. Then all these folks are going to end up just like clicking a button and giving the agent some instructions to create code that, as long as it's doing whatever the developer is telling them to do, then it's good. I'm going to just accept all these recommendations. But at some point, they're going to completely lose their thread of thought and not knowing how a change in a specific function is going to alter the behavior of the whole system somewhere else, and therefore there's going to be a whole lot of vulnerabilities everywhere. If these folks are doing that with smart contracts, then we are completely doomed, because smart contracts should be treated as critical infrastructure. At the end of the day, they are managing user funds directly. So building smart contracts using just code gens is not a very, very good idea. Maybe it can assist you for sure and definitely, but it still requires a lot of planning and thinking and following the specifications, and a lot of testing must be done. And you can automate some test generation, but then when you go through them, then you will realize that it's kind of like overfitted in the way that tests are just like made work instead of like trying to test if something is really working. And now that we have all these problems, there are not really many security researchers that can audit so much code, right? We need so many more security researchers to jump on this. We need to give these folks access to tools and workflows that are also using AI in order to supercharge their abilities and make them SSRs, like super security researchers or something like that. And especially because the Web3 space is moving very fast, large language models, like the big ones, they have a cutoff date on their training data. And if you are trying to develop or even audit something related to a specification that came out late of 2024, then if the cutoff date of the model is 2023, then it will not have good or factual information about the latest specification, and it's going to probably hallucinate or bullshit you into compliance and just follow the recommendations, and obviously a bug will be shipped. So right now, there is a lot of code out there. And if you look at this image, there is around 22 competitions going on. There is a big amount of security researchers, but I don't think that's enough, and it's increasing, and it should be increasing. And the DeFi market cap right now, it's around like 42 billion, but the compounded annual growth rate, it's estimated to be around 32 to 40% per year. And you can, especially with all these regulations that are coming out under the current US administration, you will see that a lot of code is going to be put out. There is not going to be enough people that are going to be able to audit it. So we need to help the security researchers to review code. On Cantina, for example, we are building this whole AI system in order to solve some of these problems, such as helping security researchers get a better understanding of the code base by interacting with an LLM that has the context and access to all the code and documentation, and that can save the folks a lot of time whenever they're trying to wrap their head around a code base instead of like reading through the documentation directly, or when finding duplicate vulnerabilities in findings during competitions. If you've participated in any security competitions, you will understand that judging is probably one of the hardest parts of the competition, and a lot of time goes into that. So if we want to expedite and optimize and make things go much faster, then we need to provide judges with better tools. And one of this is probably you're familiar with Clippy, which what it does is identifying relationships between findings and suggesting that, hey, maybe this is a duplicate or the other one to make people's job much better. And then there's multiple other initiatives coming out that are going to be implemented in the next months, such as custom models for spam detection. So you will completely people will be able to completely reject the spam findings and other top secret stuff that I'm not sure I'm allowed to talk about. But stay tuned. So is it really true that AI will save us? Will AI even save us? At least for the crypto security space, there is a lot of very promising developments going on. That's amazing, and we should be taking advantage of this. There's many academic papers talking about how LLMs can be used in order to detect smart contract vulnerabilities and so on. But the methodologies, in my opinion, are not really very good. If you read many of these papers, you will understand that their data sets and the way that they've performed the evaluations are not released to the public. So we don't really know if the whole training part of the LLM security module hasn't been overfitted and then tested against data it's been overfitted on. So something that would be very, very beneficial for the Web3 security space, especially with all this AI trend coming in, is to have some sort of vulnerable code base designed, purposely defined, something similar to damn vulnerable DeFi, right? But it has to be like a real code base, imitating like a regular DeFi protocol code base that should be used in order to benchmark the efficiency of these security LLMs. Because otherwise, it's promising, but it's not something very believable. And even if you test LLMs for auditing smart contracts, many of them will fail and will miss basic stuff and will waste your time. In some of the lies, you will find some truth. And what I mean by this is that maybe it will give you a lot of output, and and only one of those 10 vulnerabilities that it was supposed to detect is actually true. So here's a very straightforward example. Here's a smart contract which I took from the Securum CTF from Paris. And the vulnerability is just like an incorrect order of parameters in the the allowance function. So GPT-4o was not able to take it. It was not able to detect it. 3.5 Sonnet was able to detect it. And then if you pass this contract together with the underlying ERC20 contract and the specification, then a lot of these high quality models will be able to detect that. And this makes you think that you need to give these models as much context as possible in order to detect the actual things. And if you're trying, for example, this LLM Certic AI not affiliated agent, it's using Llama, and it has a vulnerabilities data set, but still from all the vulnerabilities that I gave it, it always gave me false positive, and there's always a critical and a high, and it hallucinates completely. So whenever someone is using an LLM for security, you have to be aware of what are the capabilities of this, because otherwise you're gonna just get bullshitted on all the time. And whenever you're asking Sonnet, for example, how were you able to find this vulnerability, right? So it tells you that it knows the ERC20 standard because it's part of the training data set. It knows the specification, it understands it. It knows it's taken our vulnerable contract, and because it also has access to ERC20 specification, it did some pattern matching, and it found out like, hold on a second, this function is not actually following the specification. This is extremely powerful for security, because now you can essentially in real time check if you're following the specification or if you're introducing like vulnerability somewhere else in the system just by doing simple pattern matching. So security agents, all security researchers should be using some sort of LLM or custom developed agent. Do take into account that whatever LLM or system that you're using in order to help you review code or understand it better or whatnot, it's heavily dependent on the underlying LLM capability, such as what we saw before, the training data set, it's fine-tuning. If it's a general purpose model against a custom one, only it's specifically designed for code. But you can definitely use this to do pattern matching, such as what we saw in the example before. You should be able to look at a contract that has some potential vulnerabilities and start matching it against like on specifications in order to at least make sure that, hey, this contract is implementing the specifications correctly. And if something is off, then you should be looking into that. Also, what I do envision, because these tools, these agents and frameworks are becoming much easier to use, at some point, you as a security researcher are going to end up creating your own database of findings, some RAG, right? Also access to links. And because imagine this case, something that personally happens to me a lot is that I have 1 million resources categorized in multiple ways across all these different platforms, and I still have difficulty to find the link of the resource that is going to solve my current problem at hand. It's like, I know it's somewhere, I saved it, I've been there 100 times, but where is it? And then I'm like looking and spending time. So if you have a RAG with all the links and knowledge and resources that are useful and valuable to you, then you would only interact with your local model and say like, oh, so what was this platform where I could see the EVM codes in real time and execute them? Oh, exactly, that's it. Thank you. Boom. Immediately, you're going to have immediate access to all your resources. So you should use this as an extension of your brain and build up your own custom system that helps you do things better, as well as doing your own workflows, right? So the one that I showed before in the video about downloading a GitHub repository, compiling it, running the tests, you could do something similar. So I have an agent that goes through all these competitions, downloads the code, compiles everything. If there is a compilation error the agent should be able to figure out like what's the way to solve that error, and finally compile it, run the tests, and then based on some specific guidelines that you have designed for the agent, such as go through all these functions and make sure that they are following the underlying specification. Then you go for a quick workout at the gym, and then you come back and the agent's done all this groundwork for you, and you check the report. Okay, this is interesting. Maybe I should look here or there. So you should be able to customize and create an agent that it's some sort of like a body, in a security researcher body that helps you audit stuff. And if that would be ideal, right? Now, for what are autonomous AI agents, not using this example, of course, this is, some people say that this is an autonomous AI agent. Well, it's not. It's a wrapper. It's a wrapper to Llama with some RAG. That's what it is. But this is what I imagine or envision what a real fully autonomous auditor agent looks like. As you know, you are a bit familiar with the frameworks that we spoke about. It has access to different modules, such as memory engines. We have short-term memories. We have long-term memory. We have the LLM. We have the reasoning. We have access to different tools. And essentially, fully AI auditor agent is going to be able to interact with a client, or also with a security researcher, if it's your buddy, then do a whole lot of planning and find vulnerabilities and actually prove empirically that these vulnerabilities are real and are exploitable. Minimize the amount of false positive as much as possible. So you could imagine a workflow similar to this. So the AI agent interacts with the user. The user tells him, here, I want you to do a security review of my code base here. Cool. Okay. So the agent downloads, navigates to the repository, has access to the code base, compiles it, checks all the documentation, and then executes an attack plan. And from that attack plan, it creates lots of different tasks and goals and stores it into the short-term memories, and they're always accessible in order to make sure it's like a program counter here. So to make sure that the things are like progressing, and if they're not progressing, like what must be done in order to keep on progressing, then compile the code, execute different tools, execute a static analyzer and see the output. Execute, let's say, if there is if the code base is implementing any other testing suite, that also execute it and see the output. And then go through the whole code, and based on our database of vulnerabilities, see if the spec of any of these vulnerabilities that are in the database could be detected anywhere in the code. Okay, go through all the code, check, could this be here, do some pattern matching, whatever it is. It's also going to be put aside with all the rest of the output that we mentioned, such as like this output of the static analyzer and the tests and so forth. And then this is going to keep on increasing the program counter, right? Like that's what the next task is going to be, this, and the next task is going to be that. And then after like getting a lot of information, if there is a new spec that has been released at the late 2024, then it will access Google, look for the specification online, and bring the specification, get a very good understanding of it, and then check this spec against like some of the findings that it found, and so forth. And then for whatever is already kind of clear, there is these vulnerabilities that exist in the code base. It's going to generate a proof of concept for each one of these, and it's gonna run them in a sandbox. Imagine a sandbox here, for example, Foundry. Whenever you're running a test, it spins out Anvil, it runs it, and then it like closes again, right? So it will generate this proof of concepts in order to make sure that the vulnerability is actually a vulnerability and that can be exploited and that it's real. There's some extra machine learning components that we can use here in order to make the system work even better, such as using reinforcement learning, positive and negative rewards, in order for the agent to generate inputs, some sort of like in a fuzzing style, on call functions in such a way that make the whole system go, the code base that we're auditing, go into an incorrect state. And you can actually guide it with different kinds of rewards. And after that, it knows which ones are like 100% correct, deliver a report to the client, all the findings, everything that's new, all these new vulnerabilities, boom, stored in the long-term memory and retrained with that. So it's better for the next time. And of course, it has access to a crypto wallet. It should get paid on crypto wallet. And essentially what we're going to get is this, right? This is an image from a reinforcement learning agent speedrunning Pokemon. And it generated like so many multiple instances. And the idea was that it was like fuzzing everything until it got to the path that led to the successful state. So what can we expect? Well, we are going to, what I would say is that security researchers are going to and will have to get used to using LLMs and these AI tools in a much more efficient way, create their own workflows, probably even create their own agents for their own custom workflows. Be sure that, be chill, calm, security researchers are not going to be replaced. That's almost going to be impossible. In fact, we need more, right? So the replacement rate here is non-existent. There's going to be more tools for auditing code, right? So imagine that we have something like this available. That would be a complete game changer. It is possible to do it, actually. There's many different companies that are doing things in different ways. And on Cantina, we're going to be doing something also probably very, very similar on the way that we're building our whole AI system on the platform. Who knows? Maybe we're gonna get some self-healing computers, self-healing smart contracts, agents making upgrades automatically whenever a vulnerability is found. So big things ahead. Well, this said, thank you very much for sticking up with me for so long. Here is a small glossary of words that could be of your interest, and here are also links that from content that was mentioned across this presentation. And if you want to sync up or ask me any question or just engage in any cool conversation, then feel free to ping me anytime. I'm more than happy to help. Thank you.